Hello everyone, my name is Jesus Armijo. I'm going to present my paper that is entitled Angela, HTTP Streaming and Edge Computing Simulator. First, I will do a brief introduction of the topic, then I will explain the motivation of this work. Then I will explain the Angela architecture and the modules that are in the simulator. After that, I will explain the metrics and evaluation that provides Angela, and I will finalize with the contribution, question and answers. Video streaming traffic today represents a significant fraction of mobile network traffic. The two main reasons of that is the merger of technologies such as HTTP streaming and the improved capabilities of mobile devices. Multi-asset computing is an emerging paradigm that brings storage and computing power to the edge of the network. This is closer to the user. So it offers key capabilities such as proximity, low latency, computing power to different applications that are deployed there. So for example, video streaming can leverage these edge computing advantages to improve the content delivery. For example, using the computing power to run AVR algorithms that are deployed at the edge. So we can see here that the edge computing node is located between the video server and the different clients. What's the motivation for this work? So what makes Angela different from other simulators? So basically, the radio layer in mobile networks is really important. It involves different complex processes that affect the final throughput available to the user. So network simulators that want to achieve a really accurate radio layer should implement those complex processes. But that's the simulation the simulation time, it increased a lot because this process takes a lot of time. So we think that we can solve this issue by importing. Angela imports the radio layer data. It doesn't need to simulate them. So you can take it from a data set for other simulators such as NS3. So each time that we run the simulation, we don't need to run the radio layer, because also Angela focuses on the video streaming process and the edge computing, not on the radio layer. We don't want to change radio layer data. So basically, Angela provides an easy access to radio metrics and metrics and all different client requests. This is really important for the edge computing mechanism that they use this method. Also, it provides a simple deployment in pipeline. So also a support for machine learning techniques that are really important nowadays. And yes, also Angela supports AVR algorithm located at different points of the network. So not only client-based we are used to, but also edge located at the edge node or located at the video server. Also, Angela provides realistic content provisioning. We can use different video data set or also create our own customized data set, selecting the video and the codec and the bitrate ladder, for example, among other different parameters. So this is really important for if we want to have an accurate simulation focus on the video stream. Now we'll talk about the Angela architecture, the different modules. Angela is written in Python. In this light way, we will see this in a few slides in a simulation. And also it can be executed on different operating systems. Basically, Angela has 4 main modules. This is the radio module. This is the content provisioning module, network module, and finally the QoE evaluation module. So we will see each of these module individually. Sorry. First is the content provisioning module. There are 2 options regarding the content provisioning in Angela. First is we select a video, we perform the segmentation encoding. So we create a custom data set. So we have to choose features such as the video, the codec, the bitrate ladder, the media delivery format, and the segment duration. The second motion is to import an external multimedia data set, and we can use it for the simulation. So as we can see, we have the input is the data set or provide the video and the parameters, and the output are just the segment of this video process that will be the content we will simulate. Then we have the radio module. We have basically two alternatives to simulate in the radio layer. The first one is to import the radio link information for the real trace dataset. The good thing is that it offers realistic radiometric and low simulation time. Also, we can import radiometric from the NS3 simulator, so we have to simulate this before, but we simulate once and then we can use in more simulations. So the high simulation time is only the first one, and it's because of this NS3. So basically, the advantage here is that we can create a custom data set. If we have to use real trace data set, we cannot customize it. Angela reads this network in both options. Angela reads the network trace over time. This can be read the downlink, that can be the modulation coding scheme, always per second or millisecond basis per user, and it will calculate the lines between different network entities. So basically, the input, as I say, is selecting the data set or simulating an S3 if we have to do it before, and the output is the radiometric over time per each user. Now we will go to the core module, that is the network module. The network module is in charge of simulating the video streaming session. This is transmit video segments through the network according to the different HAS policies. The configuration of this module is simple. We have some general parameters, such as number of users, prefetching policies, premium or basic the distribution of premium user in case we can, because in Angela we can, for example, deploy an edge mechanism that has some better treatment for the premium user. So we configure this here in this module. Also, we configure the radio parameters. As I say, we have to, if we select the data set, we have to select the mobility pattern in case the data set has a different mobility pattern. Or if we select the NS3 scenario, we have to provide the bandwidth, the scheduling algorithm, and the MIMO scheme. So we'll calculate the throughput over time per each user. Also, we have to select the parameters. This is if we select a data set directly, or we create our own custom data set using the to select which video and the encoding and segmentation parameters that we saw before. Also, we have HAS parameters to select. This is the the ABR algorithm and which parameters of this ABR algorithm. For example, we can do it per user. I mean, we can use the same ABR algorithm for all the user, or individually we can distribute it. And also the parameters, because for example, maybe we have to change some parameters to try to improve the performance, so we can do it. We have all the flexibility to do it. The inputs of this module, the first is the radiometrics from the radio module, the segment for the content provisioning module, the simulation parameters, and the output is video session metadata that we will go to the QA evaluation module. We will explain this later. And the evaluation metrics. These evaluation metrics, again, they are very customizable. So for the bitrate, the mean bitrate for each user or for a group of users, we will explain this later. So the main network architecture we implement inside this network module has 4 entities. The first one is the video server. The video server stores the video dataset with all the segments with different qualities, and it will receive segment requests from the edge node, and it will serve the segment. Then we have the edge computing node that is co-located with the base station. And this edge computing node, it has deployed all the different edge computing mechanisms we want to test. It is in the middle, so it will, as we see in the first slide, it receives segment requests from the user and forwards to the server, to the video server, and maybe modify it depending on the edge mechanism, and also receive the segment from the server and serves to the user. Then we have the base station that is manage the radio layer and assign the throughput to the users. And then we have the users. The user consume and request the multimedia content according to the AVR algorithms. Finally, we have the QE evaluation module. This QE evaluation is in charge of providing quality metrics of the video streaming for each user. It follows the ITU 1203 recommendation. This recommendation describes model algorithms to the session quality of video streaming. Also, it considers the main factor that impact the final QE of the user, such as display properties, bitrate, number of stalled, ratios of stalled, segment switches, and those kind of metrics. The input is easy. It's the video session metadata. This is some JSON file that the module generates. And the output is this per second quality score, the styling view, and the final QE score as per the ITU 1203 recommendation. So now we will talk about the adaptive bitrate that we can use in Angela. This is a key part of the simulator. Angela has different AVR algorithms located at different points of the network, but it's not restricted to those I will mention. The flexible architecture allows to implement more AVR algorithms and located at different points of the network. So right now, what we have implemented client-based AVR algorithms are buffer-based algorithms such as BBA, throughput-based algorithms such as TBA, then hybrid-based algorithm. This is a segment-aware rate adaptation algorithm, SARA. And also we implement 3 different edge-based algorithms. Those 3 edge-based are state-of-the-art edge-based from different papers. The first one is called Edge Assisted Adaptation Scheme for HTTP Adaptive Streaming, EADAS. The second one belongs to the paper that is called Edge Computing Assisted Adaptive Streaming Scheme for Mobile Network. The algorithm is called greedy-based bitrate allocation. And the third one is Edge Computing Assisted Adaptation Scheme with machine learning for HAS. It's called ICAS-MN. As you can see, we have an example here of AVR algorithm that is deployed at the edge and use machine learning capabilities with, as we can see, Angela support those characteristics with no problem. Sorry. Now we'll talk about the metrics and the evaluation possibilities that Angela provides. So Angela provides a wide variety of metrics to evaluate the performance of the video streaming session. And the flexibility of the testbed allows the implementation of new demand metrics really in an easy manner. And these metrics can be presented in a different format. So for example, we can have this metric per user or average a group of user or maybe the premium user as we want. Also, we can provide the average values or the values over time. Again, we have a high flexibility. Here we do an example of this. In this example simulation, we evaluate 3 different client-based AVR algorithms. TBA, BBA, and SARA, and then we evaluate an edge-based system, which is IADAS, SARA IADAS in this case. So table is just an example to see what Angela can do. So we have here the mean bitrate, the mean switch magnitude, the mean switch magnitude, but measured in quality index, number of stall, the mean stall duration, and the QA score according to the P1203 evaluation. So those metrics are provided at the end of the simulation in a really easy manner. As we have here a graph, another type of data that we can represent. So here, for example, for SARA, we represent the segment bitrate over time. So we have here the segment bitrate in the red color. Then we have the radio throughput and the quality index that is in this axis, in the right y-axis. So we can see how the segment bitrates are evolving over time. The quality index, in this case, we had like 0 to 19 qualities. So we see how it evolves over time. We can, of course, see the correlation between the radio throughput and the segment bitrate, and we can see that the possibility to evaluate with Angela are a lot. This simulation is 2.1 seconds in Angela, and we replicate this simulation in NS3. So with the on-off application, it took 5.6 seconds. But this is because we use the point-to-point topology, and still the simulation took so much longer. If we try to, when you use the LT model of the NS3, we see that the simulation took 764 seconds. So we can see the difference in time of those two simulators, and we can see here the advantage of Angela. As we focus Angela on the video streaming of the edge computing, for the radio layer, that is what takes more time to simulate, we just use a real radio dataset. So the more radio layer is really accurate. We overcome this kind of high simulation times, and we have still really good, really accurate results. So I will finalize with the contributions. The first one is the content provisioning of module of Angela enables to create customized multimedia dataset with different configuration that later will be used in the simulation. Also, we can use different and state-of-the-art multimedia dataset in a simple manner. They are already implemented in Angela, but we can also include more. Angela can use real radio dataset from a state-of-the-art dataset that would result in a more accurate radio layer simulation. But also, as I mentioned, if we want to create a customized radio topology in NS3, we can do it, and we can import that scenario. Also, Angela focus on has a VR algorithm and edge computing mechanism. It supports matching techniques, but anyways, Angela is lightweight. It provides lower simulation time as with the previous slide, that other network simulation. Also, it supports a VR algorithm deployed at different locations of the network, such as the client or the edge computing node. Angela also offers adequate performance method to evaluate different video streaming sessions. Moreover, we don't only have the P1203 QA evaluation model, which is very useful, but we can also have custom metrics. And finally, I have to say that Angela is not yet publicly available, although we plan to do it, have plans to release for the future. And Angela is also approved and used in the evaluation of two accepted papers, that is the IADAS and two edge-based mechanism. IADAS that was accepted in LCN, and ICAS that was in the MMM. Thank you so much, and if you have any question, I will be happy to answer.